Hi everyone, I'm Valid and I will welcome you to the channel. This is our fourth video for the drainage design. If you're following along, you know that we did some of the pipe network, we did the catchments, a little bit of pond design. And in this way, today we're going to see about some of the changes make to our pipe network and then try to check our pond and then we will rerun the analysis to see what we found and what will be the other changes that we will need. So let's get started. As we have the flow path here, I'm going to see the latest flow path was this one. And now from this window we know that um, where this is going very deep, this isn't the way it should be. So this is our locked, I would say our locked invert level for the outfall, and this is the invert level of the pond. We can't go any deeper because this is our outfall. So we have to first do is to select this pipe, double click, and now we will see a bit, it should come at bit this one. So we will see upstream. So this is called the upstream invert level of the pipe, and this is known as the downstream invert level of the pipe. So we are looking for the upstream invert level. So from this one, we know the upstream invert level, and now we're going to change it to, let's say, 4.5. Let's enter. Let's say apply. Now I think is bit better now. You can see it has been updated. So 4.5 is the limit that we can go. Now what we're going to do is we have to lock this manhole so that once we design our network criteria, then it shouldn't change, that this will be fixed. So we want this to be as a fixed, we don't want it to be changed. So now let's see how we can do it. So I will just click OK, close this one, and we can maybe create a new phase, let's say, so that we will create a new phase. So this is our second phase that we will be working on. Second, select here, second. Now let's fix our pawn at this one. So this was 445, yeah, 4.5. Now I would say start from, so double click, so now we have to lock it. So if you go to the connections, double click on the connections, so pipe number 13, into the pipe number 13, also we change the dial to 300 because it's the downstream. So, and we will change, we will need, okay, so we need another column where we can lock it. So from the columns you can go there, and we need invert level, so minimum downstream invert level. So we'll select this one. Now this one comes with minimum downstream invert level. Now you can see this one here, and we need the pipe number 3, so it is 4.5. So we'll click apply. 4.5, now it's locked at for the pipe. 4.5 is the minimum downstream invert level. Click OK. Now we go again to the building sizing, network design criteria. First we will select the criteria, that is for 30 years 5, and everything is okay. Click on the design options. From the design options, minimum cover depth is 1.200. Well, we can change it because it's a residential. We can also change it to 900 millimeters. It that might help. And from here you will be able to see this one, minimum downstream invert level. So we have to check this one because we want now fixed outfall. So once you will check this one, it will give some of this note that selecting the minimum downstream invert level can result breaking cover depth and slope conditions. So it's not because every site is different, so it's not possible every time to have the exact slopes, to have the exact cover levels. So with the changes we will make for our site, we will know what we can do, what is the best solution, so that our design is safe and workable. So this is all good. So we can do, everything is fine, and we can just click OK. Now we have set our design, net design wizard, and this is for the flow path. We want it flow path 5. So next, so now it has updated from now on. With again, it has showing you the nodes. Now it has updated with the cover depths, showing that these minimum cover depth not met. So it's because obviously we have changed, we have locked our outfall. So it means the terrain of our site is not very good for the laying the main holes. But you can see the cover depth is 0.122 and everything is like this. So we can, let's, for the pipes, and this one for the manholes is, the yellow ones are only the changes it has made, and pipes are basically the depth. So we'll see. Now we finish this one and the changes has been made, and now we will quickly see our profile. Now you can see it's bit changed now. So we are getting somewhere, I can say. If we make it a bit bigger, so first of all, the manhole is too deep. We can change the depth already to increase 600. So manhole depth is, we can just change it from the depth. Maybe this way will work still. So from here we can see if they go to this way, it's still very flat, I think. Well, let's decrease this one to how big is this pipes are. So pipes, so 5.5, maybe we can go to, so it's very close here, so maybe we will change, but if first we have to analyze if this works or not. If it really doesn't work, so it's no benefit of doing this one. We can just try to quickly do the rough guess of the model, that if we need anything else. Also quickly drag, and I also want to remove the catchments, not remove, but don't want to operate. Display should have the display section. So display settings, and turn off the inflow outlines so that we don't change that. So make it a little bit bigger to see if that will work or we still need to find some other solution. Now double click on the pond. Now we'll have some to see. So we will just click OK. And we'll try to rerun the analysis. I will first save it. Oh. So we go to the analysis, validate. Okay, we will just run the analysis. So this is how we make some changes to see if our model is working or if it's totally not working. Maybe in this drawing I can't see any other option to put pond or something like swales or anything. So maybe porous pavement could be a solution. So I will see. So 33% available, negative 33 is means that it's still at flood risk, but minus 33%. So we'll see how it's performing. So if we go to the results, check for the junctions. So some are surcharged, some are flooded. And if I look for the manhole, so we are looking for manhole 1, 2, 3, 4, 5, 6, and 7. So one is flooded. Obviously, it was. So still, I think we still need to provide some of the porous pavement because it's not going well. Well, we can see mostly is one in, you can see 100 years, 45% allowance, 15 summer. So we go here, look for 100-year, 45%, and then 15 summer, winter. So now you can see that this has flooded. So all the red ones you can see are the flooded ones. And we also have the flow path here. So we go check the flow path to see how it was flooded. So this one has the capacity. This one has the capacity. This is still up with make down, but this is flooded a lot. So because you can see this red line, so it's totally above, so it means it's flooded. Or we can go deep and then the slope, maybe that could help. Or what we can do is provide some of the porous pavements. Let's run this again to see. So if we can increase, if we should increase or first we can try that. I think if it's the manhole is a bit deeper, that could be help. This could be helpful. Or if not, then obviously we can go for the other design. So let's change. Let's make some changes to this model. So we like to go for this one first. So now I have more depth, a little bit more. Now that we have this value upstream invert level, so this is we will just copy, we will paste it here. Just so this one, and we will copy the upstream invert level 4.421. Click OK. Now either we try for the wizard. Also we have this manual. We can just lock all at the moment, and we'll click OK and try to run the wizard for 5. Next downstream. Show the profile. It still go down. Well, we can make some changes manually, I would say. So we have to go one by one. Downstream invert level. Maybe 599. So yeah, I will do it quickly just now. Well, I think it's better we can just go with the porous pavement first. Maybe that would work for some of the models. So what I can do is we can just create a new model, and we can say search. Now we can just draw some of these porous pavement. I can see this one. So in order to draw that, we just go to the stormwater, and here we can see the porous paving. Drag this one here and turn on the snap mode. So maybe we can just draw some of these. So it goes like this. So maybe like this. Or we can draw some of the so same here. Draw across the road. And draw it here as well. Now right click, select, I will select this one, replace outline, freeform. So this, right click, hit close now, and I will select a tool, and let's say we want to change the properties. So this is basically this one. You see the existing exceedance level that comes on the top level. So this is basically the exceedance level that's on the top level. You can see here. So this is come from the cover level, from the surface, and then the depth could be the total depth. It is from from the exceedance level to the base level. So this is the exceedance level, and this goes all the way to the base level. That will be count as a depth. So we can do the depth of 50 millimeters, and paving depth is 100 millimeters. So pavers, so this one is paver. So usually pavers are in 80 millimeters and 20 millimeter for the joint, so 100 millimeters. Percolation membrane, we can put it as 0.02. porosity is 30%, and slope we can put in slope 500. Okay, width, because we draw it automatically, so it comes with the width as well. And we want under drain on, and that will be. We don't need the height from the base because we just want on the base. As we don't have any infiltration or anything, diameter is like 150 millimeters. Number of barrels, like how many pipes, one pipe. And release height, we don't need the release height. This one Mannings is already here, so we will just click OK. Now that we have this one ready, we can create a template and name porous. It should have this one, so porous pavement 1, you can see here. So now if we draw these ones, so this was, we delete this one, draw the porous pavement, and we just need to replace freeform, and we will just replace. Now select. So you will see it has changed this one, but other things are remains the same. So this way we will have the porous pavement for our side. So I will draw quickly rest of them. So I have done it, some of these ones, and now we have to make sure that we connect these to our catchments. And so this catchment, we will reconnect this one to this one, and then this one, and a big catchment here. So this catchment we can reconnect it to this, and this is big area, so we need one more catchment. Reconnect this one, and this will go to this one. And then we can this, and this will go into this one. Well, we are working currently, so I just use this one to see if these are enough or if this is the right way we are going towards. So I just click select tool. Now that we have this one, so we have to connect the pipes to the this one because we have put the under drain as well. So under drain is basically this pipe. So this pipe is will, as you know, this is the soil is clay, and we cannot do the infiltration. So that's why we are putting this pipe, like the water will come and store into the sub-base reservoir. From sub-base reservoir, it will go to the pipe, and from the pipe, it goes to the drainage network. At the moment, we are not doing any infiltration, so I think we have to, yeah, it should be 0. And conductivity, we can put 0.1, the minimum. Otherwise, there shouldn't be any infiltration here. So click OK. Now we will just connect the pipes to these ones, and let's do this. I will just delete this one. Yeah, now we can have this panel to this one. because this pipe was too deep, so I would say that we can draw one also to look into our profile. So this one was, I think, good. It can go deeper to match this, but this is too up, so we can also draw this manhole porous paving here and select replace the freeform just to the entrance. We may have to provide change. I will change 550 main road. Everything looks good. Almost the flat lines. Now I will connect. I did this pipe on my home, and we'll just save it this model and do the connection network and do pipe. So this pipe will connect into this one. This will go to this one, and this will also go this one, and from this it will go to the inlet, and this will also goes to anything else, other connections. So this will may need one manhole here that we can connect these two. So build manhole, one manhole there. Select delete this pipe connections. This to this, to this, this to this. And I will say that's it. Now we'll just no, it's tricky one, right? So we will just change that pipe. What pipe diameters are these ones? 375. So let's just use 375 for this one as well. Some slopes are not correct, I can see here. So 375. This one will also, some slopes are not good. These pipes should be 150. So 150. Why it takes us to there, mate? It should be just now that we have made some of the changes. Now quickly set the profile properly. Okay, so that we have to draw yeah, because manual is 0. I'll save it, run my wizard. Flow path number, latest. Flow path, this one. So I will just do this again. Change this one to change the pipe downstream inward level, maybe 5.3 upstream is also. So pipe number 2. So what is it? We'll see for this one. This has the upstream inward level 5.188. So 5.188. Downstream inward level 5.188. So a little bit over 200. Now this way. So inward level 5.243. 5.243. Upstream inward level 5.2. I think that should fine. Also, I can say that we can go deeper as well. We have this one. So how deep is this? Let's go deeper. Inward level of 4.421. Inward level of 4.421. 4.421. 4. A little bit of 50. 600. All right. So now what we have to basically do is make a nice profile of it. The depth will also take some of the water. Then this will also, if we do a bit more deeper, then obviously we can store a bit more water into the manholes. And this, if this goes deeper, then this also will go deeper, and then we will have a more cover level. I think that would be safe side. So we can do that. So we can do a little bit, go deep for this one as well. We can also, in this way, if you do the depth, you select the invert level, you change these, this will automatically update. So two of the items are manual, one will be automatically update. So sometimes you put the invert level, sometimes you do the depth. So this one is easy for me. For the depth, I can change to 300, and on this screen also looking at this one to see if any changes applied. So we have more space. So this is the good thing we can see and do these ones. And now again we do, I think 400 will be fine. So that flow goes, and now we can just click OK, double click on this manhole, go here, depth is 1.10, yes, double click, goes to depth of, I think we can go for 1 to 1. It's a bit more deep. Still, we can have the opportunity to no. Let's try. Nothing bad in trying. A little bit with the 1.3. I think 1.750. I think so. That's fine. Yeah, I think this should work, right? I think we can. Zero point 900. Change it to. Oh, I can this upstream invert level. We can change this because we are doing manually now. So change the upstream invert level. I think looks a bit better, but I'm not sure. More deeper. Cool. Save. It should be more deeper down. This is basically the water course that we have here. So we have this water course here that we are trying to for our outfall. So this can comes from the section of the water course. So it's just random invert level that from here water will go there, but not going too deep. Mhm. So we'll just do this, click everything, okay, save again. Let's draw the flow path for this porous pavement to see this downstream manhole show the profile. And it's some water flowing into this one. Slope is looking fine, gentle. So, yeah. Also, we can draw the profile. Just some quick checks. Slope is good. This one is good. So I think we can just try to solve this area first. And now we can do the prelim sizing analysis validate. Oh. Okay, conductivity. They need us to put the conductivity should be 0.7. So these are a lot of things. We can just save first analysis conductivity. Or you can do one by one, or you can do from the tables, whichever you like. For example, if you go to the tables, stormwater controls. So I don't want it to crash again. So double click on the tables. Junctions, stormwater controls. It isn't coming here again, so I guess it's well, it's not coming here. I think I need to restart my InfoDrainage, but we can also do quickly as well. So I will just quickly do this for So I can do is one more thing. I think we can try the tables, and I guess okay, now it works. So we can select our junctions, stormwater controls, and go for our tables on porous pavements. Only the porous pavements. So we need the conductivity calculation. So this one, we don't need high 100 rand. Okay, so conductivity, as this is a porous pavements, and we use open graded sub-base material that, for example, so that water can store into the reservoir. For that purpose, we for the real life projects we use a value of between 50 meter per hour, but it's basically gets you from the BRE results or the designs you will be doing. So I will be putting here as 250 will be my 250 meter per hour. I will put the conductivity, and the membrane percolation is basically the sub-base, the water, how much the water percolates per hour, and we don't have sand or any fill material here. So for this one, I also have the report for, I use 2.5 meter per hour. So I what going to do is just quickly update, but this seems to work. Now I will do the conductivity, change all of this to what the report says, 250 per hour, and change this way to 2.5. So this is reports on your on design, on your other criteria that you receive from the ground team. So this is for it. So we can do quickly from it. Click OK, save, validate again. So the pipe number 30. Upstream inward level is below upstream inward level below the base level of the cylinder. So pipe number 13. What is the pipe number 13? So we can see this one. So again, connectivity. Well, we have updated this one, connectivity, right? Okay, it didn't make the changes. So conductivity 2.5 equals is 250 equals apply. Okay, save. Now analysis, validate. Now we see the unconnected stormwater junction board. Okay, we have to also connect the stormwater junctions. We will do that in a second. And the pipe number 13, what's the problem with the pipe number 13 here? Let's see our flow path. Show the profile. Upstream inward level below the plate. So upstream inward level. So this one upstream inward level is below base level of the. Okay, so this pipe is match. So apply. Well, we can apply. Now we can see what was. Now it's a bit changes, so that's still okay. And we can validate analysis. Unconnected. So yes, we have some of the unconnected. Pavement 1, 4. So this one we need to connect this, and we can do this by doing the build connection. Inlet, change the pipe to 150, because 100 millimeters will be too small, I think, for the resin. So it's better to change size a bit bigger. Now we can have our profile. Looks good. Let's save the model analysis, validate, click flow analysis. This is all about design work, is what is the best solution we can have, so that also we have to be sure that it should be economical and it should be safe. So this is all the iteration we have to do. We can also, I think of the way that we do all of this porous pavement, like this main road should be porous pavement, but it depends if that works. So the critical analysis. So mostly are flood risk and some minus 88 were at the flood. So mhm, flood, flood. Okay. How about the pond? Pond is still in the flood zone. So I think so. This is quite tricky side, right? Okay, so what can be the other flood risk? Porous pavement, mostly storms, hitting different kind of storms that are hitting differently to this side. Mhm. So flood risk is, let's check for the analysis. For 100 years and 45 uh, this storm. And we do, what's this window? Uh, and draw, show the 5. So let's see what happens here. So that we have the idea. Very quickly. Oh, the upstream pipes are still flooding. So I might think one of the five and go to the results, stormwater controls. Junctioning porous pavement number 11. 60 minutes winter. 60 minutes winter. So it still have some space, but this from here it touches this one. Solution is we can go a bit deeper for this porous pavement. Okay, so that might be the good solution. We can go a bit deeper, or what we can do is a bit more slope, or we can increase the pipe size. We can increase the pipe size, that will be the flow will be faster. But we can see this tailwater. This comes the water, that's why it's choked here and the water fills up. So we need some more storage here. So storage will be done by what? By increasing the size. So increasing the size will keep the water stored, and then this will go downstream, or we can, it stores here, or we can do a bit of slope here. Well, this is a different solutions that we can look into. Let's look for the other one which was flooded. This one, flooded 30 minutes winter. 30 minutes winter, number 6. First page number 6. This one right there. We don't, I think we don't have the profile for this one. It was so much up. So it's been flooded a lot. The downstream manhole has a capacity. This comes. So where did it fail? Failed at this point. Oh, it's going backflow. What the solution should be? Again, as we deeper this one, it can help us because we are a little bit up. The line is like 6.1, so 100 millimeter. So we can go down 100 millimeter. That would save us, or 1.5, and then maybe this will save us. I'm running out of time, so I think we will see some of the solutions again. Yeah, but I think you will get the rough idea of how we allow the solutions. Maybe now we can try and put it whole of a permeable pavement. That will be good storage, but that could be quite expensive as well. Or we can put some of the more porous pavements on our way. That can be helpful. So these are the different solutions that we have to think of, but I think for today's session is quite a lot to see how we can work the phases, how we can do the porous pavements, the pipe network. So we will look into this one a bit differently. Maybe this is whole can go porous pavement, then we will just get rid of our this pipe network. I think that will, because otherwise we will have a lot of pipes, the taps. But if we do the whole this as a porous pavement, then this could be a better solution. Yeah, I think so. Otherwise we will end up doing a lot of pipes within this one. We also need the foul water pipes. This connection will be to goes to, by the way, this one can be joined. Then we need the colors. So yeah, we will see what solution we can have, or if you guys have any solution, you can just write in the comments and we can try in the next video. I think that would be also handy. Okay guys, see you in the next video. Thank you for watching. Bye.